An expanded octet occurs when you draw a Lewis dot structure and there are more electrons than needed to satisfy the octet rule. So we want to remember that elements in the third period and below can accommodate more than 8 electrons, because at n equals 3, or the third shell or third energy level, that's when the d subshell becomes available. So the n equals 3, the third period and below, all have d subshells available to use. Now as we're drawing the Lewis dot structure, any extra electrons are going to go on the central atom. So if we take a look at the periodic table, we see this is the third row here, first, second, third. So we're mostly going to be focusing on nonmetals as we look at Lewis dot structures, because we're going to be looking at sharing electrons, and that typically happens with nonmetals. So here's our third row, and any element third row or below can accommodate more than 8. So let's look at an example. What I'd like you to do is draw the Lewis dot structure for sulfur tetrafluoride. So just stop the video and draw the structure, and when you're done, start the video again. Alright, let's check your work. So hopefully, the first thing you did was count your valence electrons. 1 sulfur contributes 6 electrons, and 4 fluorines contributes 28 electrons, for a total of 34 electrons. Okay, so after we count our valence electrons and know that we have 34 to work with, the next thing I'm going to do is arrange my atoms around my central atom, the outer atoms around my central atom, and draw a bond between my central atom and each of my outer atoms. And since there are 4 fluorines, that means I draw 4 bonds, which uses 8 electrons, since every bond uses 2 electrons. So after I draw my bond, I have 26 electrons left. And the next step is to distribute these electrons as lone pairs on the outer atoms. So I see that I have 4 fluorines, and each fluorine needs 6 more to satisfy the octet rule. So 6 times 4 is 24. So after I distribute those electrons, I'm still going to have some left over. So here is my Lewis dot structure, and what do I do with these 2 electrons? Well, I place them on the central atom. Now one thing you do not want to do, you do not want to straddle these electrons across a bond. You don't want to make like a division sign. Each pair of electron is going to be separated from one another, and we want to sort of acknowledge that in our Lewis dot structure. So it doesn't really matter where you put that lone pair, but you don't want to, as I said, straddle a bond, and you also don't want to stack. If you had more than one lone pair, you wouldn't put the other lone pair on top of it. You would put the other lone pair between 2 other bonds. So we want to separate our lone pairs and our bonds as much as we can in the structure, and put any extra lone pairs on the central atom. Now the last thing I want to do is I want to make sure that sulfur is in the third row or below, because the Lewis dot structure as I drew it had sulfur with 10 electrons, and I do see sulfur is in the third row, so our Lewis dot structure is fine and sulfur is allowed to have an expanded octet.